somebody did the integral of 1 over x to the 18th power plus 1 legitimately, meaning all the partial fractions, all the algebra, all the system equations, all the things that you see right here, which I'm not going to do any of that, because if I do, I will probably stay here for like 10 hours and then make that 100 mistakes or so. But make sure you guys do check out the original post though. The link will be in the description. Right here, I do want to tell you, for this kind of functions, you can actually use power series to integrate it, especially if you are taking a calculus 2 class and see this on your final exam, then this is most likely what you are expected to do. So let's have a look. The power series for 1 over x to the 18th power plus 1, well, you will have to know our best friend to start off with, which is 1 over 1 minus x. That is the geometry series, and that's our best friend for power series. It's a series as n goes from 0 to infinity of x to the nth power. That's it. But you should also know the technical part, and that's the interval of convergence, meaning for what x values will make this legitimate. And that is the absolute value of x has to be less than 1. So do not plug in 2 into x on the left and also on the right hand side. Do not plug in 17 into this right here. But 1/2 is okay, negative 2/3 okay, etc. So in order for us to use this, let's go ahead and just work with the 1 over x to the 18th power plus 1. Have a look. We are going to integrate. On the inside here, let's go ahead and rewrite it a little bit. This is 1 over, let's put on the 1 first so we can match that. And then minus though, we need a minus. But that's a positive, but it's okay because we can just write that as negative, negative. So let's put another negative and then the x to the 18th power. That works wonders. Now we can just put this into this right here. So we will get integral of the summation as n goes from 0 to infinity, and then just go ahead and enter negative x to the 18th power and then raised to the nth power, just like that. But we should also be plugging this right here because again, that's the technical part. In order for us to use this power series, we have to be careful with the interval of convergence. So let's go ahead and write absolute value of negative x to the 18th power has to be less than 1. But this right here is not bad because first absolute value of a negative, the negative doesn't matter. The 18th power can be put on the outside and then just take the 18th root on both sides. 1 to 1 over 18th power is just 1. So this really implies absolute value of x is less than 1, which is the same as the original, which is very nice. But anyways though, I'm going to kind of simplify this right here a little bit. This is going to be the integral, and then we have the summation. N still goes from 0 to infinity. Here we have negative 1 to the nth power. Write that down first, because that is like the coefficient. And then multiply the exponents. And then now we are ready to integrate. Now here's the deal. To continue, we are going to switch the order of the integration and the summation. Meaning we are going to integrate this right here first. And we can do that because we're integrating a power series with this condition here. And you can also quote the Fubini theorem, which is the theorem that allows us to switch the summation and the integration. But we don't do that in Cal 2, so usually I just tell the students from here, just add 1 to the power and then divide the power because you can just integrate by using the reverse power rule. But anyways, let's go ahead and finish this real quick. So now we are looking at this right here. To integrate this, x to some power, just add 1 to the power and divide it by the new power. We still have the summation here though. So write that down. And then we will have the denominator being 18n plus 1. And then this right here stays because that's just like a constant. And then x to the 18n plus 1. Just like that. And of course, there's one thing that we need, which is the plus c on the outside of the summation. And that's it. Yeah, this is something that you should be expecting to do if you are taking a Cal 2 class and for the final exam, or maybe like the exam that has gone over the power series, all right, which is very cool. By the way, I should also include the condition in my box as well. Absolute value of x should be less than 1. That's it.